Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. So I have already started a new series to learn the parallel computing in our programming language. So in this tutorial, I will be explaining what are the processes and threads in our operating system, how they are interconnected, and where we use this process and threads while doing the programming. Right. So let's start with processes first. So if you see the definition of process, it says that it is an instance of a program that is being executed. For example, I have some executable file that is exe, and I want to execute that on my machine. So I will load the program for that exe and then will execute that particular program. So that process is nothing but a process. Means that instance where we are executing our program, that is nothing but process. For example, let's say I want to run the notepad in my computer. I'm opening the notepad plus or simply notepad. So what I will do, I will go to my start and run my notepad application. That time one of the process for this notepad is running in the background. We can see that in our background processes. So executing this exe is nothing but a process. And another example, I can simultaneously run multiple process for the same application, right? Now I have opened Notepad three times. So three processes for the same Notepad application is running for me. And you can see the same in our task manager also. So this is nothing but process. Any application, any executable file we are running on our machine, that is nothing but one of the processes being executed in our system by operating system, right? So this is nothing but process. So how it works? So what are the characteristics of process? So every process will have their own memory, right? So likewise they will always have their own memory space. After that, another is they typically include one or more threads. So what is thread? We'll see that in our next slide. So for now, just keep in mind that every process we will have different thread, right? One or more thread. That means each process will have at least one thread, and that thread we called as main thread. So every process will have one main thread and many other thread which we can create for that process, right? And another is these processes are managed by operating system, right? So operating system will manage all these processes. So these are some of the characteristics of process. So as I given the example of notepad here, the same example I have given running the multiple instances of text editor, which is notepad on your computer. This is one of the simple example how the processes are created, right? Next is thread, right? As I said, processes and threads are interconnected. So a processes will have multiple threads. You can see in this example also this process one have this thread 1, 2, 3, also for process 2 and process 3. So what is thread? Thread is the smallest unit of execution within a process. Sometimes what happen, we have one process and that process can have multiple instruction to execute, right? One process can have multiple instructions to be executed simultaneously. That time we create the thread. So multiple threads are getting created and they will execute in our um, the process, particular process. So that's why we say that thread is the smallest unit of execution within a process. Means it is also called as subset of process, one of the part of process. So if you see the characteristics for thread, thread shares the memory space with other thread in the same process. So process can will have their own memory space, and threads will all the threads in the particular process will share the memory space. They will have common memory space which they can share, right? Also lightweight threads are lightweight compared to the process, because when threads are intercommunicating through memory or any shared resources, they are actually lightweight than process. One of the example for threads, how they are getting executed. So example is downloading multiple files simultaneously in web browser. Let's say that I have a web browser Chrome and I want to download, I have one process running there and I want to download multiple files, right? So process is our web browser. So I have opened the Chrome web browser and I want to download multiple files from Chrome. So this web browser is process, and this process will have different thread, like thread A, which is downloading file 1, thread B to download the file 2, thread C to download the file C, right? This is one of the example in how threads are getting created, or how the processes and threads are interconnected. So there is one of the another example, which is word processing. Let's say that I have word file open um, in my system. So whenever we see that in word processing software, um, it always runs a process for the word, right? And within that processes we have multiple threads that can handle the different tasks to enhance responsiveness and functionality. Let's say that I will open one word application, right? So in this application, so this is the my word application, and the process for this is which is running, which is Microsoft Word. So this is our process, right? Now, so this word application have the different tasks to run simultaneously, right? So this process will create the multiple thread. A thread one can manage the UI, which is our menu toolbars. Thread 2 can handle the document editing. If I want to type anything here, anything, so that will handled by another thread. So managing UIs will be of one thread's work, and document editing will be of others. Then sometimes in the background, whenever I type something, some spell checking is coming here, so this is managed by another thread. So multiple thread need to be executed here to run this application, right? So this is one of the example for how threads and processes works. Let's see another. So here processes can have single thread or multiple thread. We already saw that. So that with that, processes are of two types: single threaded processes and multi-threaded processes. So as I said, process at least should have one thread, which is our main thread, and there are some register, counters, or stacks. These are the sum of the part of the processes which processes use, and then code, data, files. These are the part of the process, right? Or the shared resources, or their own resources, we can see. So these are the resources used by process. Now let's see the multi-threaded process. In multi-threaded process, if you can see, there are three threads here. So multiple threads are created in our process. That time that process is called as multi-threaded process, and this multi-threaded processes, each thread will have their own register, stacks, counter, these resources for each thread, and code, data, files. These are the resources which are shared by multiple threads. These resources will be shared by multiple threads. So this is nothing but single thread process and multi-thread process. Let's see the example of web browsing, right? So how process, and I already shown the how we are downloading multiple files from web browser process, right? So this is the same example with some different functionality we are checking here for threads. So here the process is while we do the web browsing, the process is web browser, whichever web browser. For example, I have Chrome, then Chrome is a running chrome.exe, which is our process, right? And in the Chrome, there is a one thread for rendering the UI. there is another thread for handling the user input. If I am typing something in my Chrome search bar, right, that is my another thread, like mouse clicks or keyboard events, right? And thread C will fetch the data from the internet, like downloading the web page, right? So this is another thread. So likewise, this one process having the multiple threads, right? And then again there is a process B. Chrome same. I'm opening the another tab or another window of Chrome. That will be our process B. Means when I'm opening my Chrome, and in that Chrome I'm having different tabs. Each tab itself is a one new process, right? And that process will also have the different threads. Like here, this process B is also having the another thread, two threads, where one is rendering the different web page and handling the animation or media playback, right? So likewise, every process will have one or multiple threads based on the requirement. This is one of the very simple example to understand the process and thread. So now let's see the comparison between processes and threads. So there are some elements through which we can see the difference between two concepts. One is memory. So processes have the separate memory spaces, as I said before, and threads will share the memory within a sorry, it should be between the threads and within a single process. So this is one of the very important and main difference between process and threads, and that's why, because of this shared memory, threads are lightweight than process. The another is resource overhead. So with processes, we have higher overhead, example memory, compared to the threads, because threads share the memory, that's why. And threads will always have the lower overhead for the memory. Then another difference is communication. So one process can have multiple thread, and thread can communicate with one another easily than processes, because threads shares the resources like shared memory, shared variables, data structure, or synchronization primitives. There are some synchronization primitives like mutexes, semaphores, which will be seen um, in our next videos. These are some of the shared resources through which threads can communicate with each other more easily. But with processes, as the processes have their separate memory um, spaces, we need some mechanism to communicate between the two processes. For example, interprocess communication. This is one of the IPC mechanism which we use for the communication between two processes. So these are the three main differences between process and threads. Next is benefits of using threads. So what are the benefits we have using threads? One benefit is concurrency. So we have multiple threads. So these threads will allow tasks to execute concurrently to improve the performance. This is one of the very important benefits. Then responsiveness. Then threads can keep application responsive by handling multiple tasks simultaneously. Same concurrency, using concurrency. So it gives the good responsiveness. So this is one of the benefits of thread. And then another is resource sharing. So as I said, multiple threads share the resource in a process. So that can efficiently, so within a same process, that can efficiently share resources. So these are the benefits of using thread. So while using thread, there are some challenges also we face mostly. So one of these, as concurrency is benefit, but it also comes with some issues. Means sometimes when we execute thread concurrently, there is a synchronization issue. So for that, to avoid a race condition, means sometimes deadlock condition or race conditions occurs while communicating between different threads or running those thread concurrently. And data inconsistency also, because multiple threads are sharing the same resource, so that time these issues can occur. Then complexity. So thread management and synchronization can add more complexity to program design, right? So this is one of the challenge. Then performance. So excessive use of threads can lead to overhead and potential performance degradation. So if we create a large number of threads, that will also lead the overhead and it will decrease the performance. So these are some of the challenges of using thread. So this is all for the process and threads. In our next topic, we will see in details how we are using these processes and threads in our task parallel library, right? So for now, this is it for this video. Thank you so much for watching the video.